Alright. Okay, so for those of you that were not here, when we're doing this, all we're doing is looking into solving our equations. Alright? So for solving this equation, what I'm simply want to do is I need to solve for my x. Now remember guys, when you have like one x, it's pretty easy just to get that trig function with the x by itself. But here I have multiple of my secants. So one thing that automatically triggers in my brain is to start thinking of factoring. So when I'm going to want to factor, I'm going to want to make sure I get all my terms over to this left side and I can factor set it equal to 0. So therefore I have secant squared of x minus secant of x minus 2 equals 0. Now, some of you might be a little bit, kind of vague to see how you would factor this. So what I would recommend is to eliminate or just forget about the secants for a second and just see if you could factor this as it is, or this trinomial as it is there, okay? And when you do that, what you guys will notice is x minus 2 times x plus 1 equals 0 when you factor. All right? And the next thing is, remember guys, you got to remember the zero product property. When we have these two multiplied equals 0, we can set both of these equal to 0. Okay? So this is what we do, this is what we've done before with older algebra. Now all we're doing is we're going to do the exact same thing with the trig. So what I notice is I can now factor this to secant of x minus 2 and, or sorry, secant of x minus 2, and then secant of x plus 1 equals 0. Okay? Add them up. Alright, so now what I want to do is I want to set them both equal to 0. So I have secant of x minus 2 equals 0, and secant of x plus 1 equals 0, right? But ladies and gentlemen, when we're trying to find our values for secant, it's very difficult for us to figure out what secant, actually let me solve this first before I go into that. So then I'll solve. So I have secant of x equals positive 2, and secant of x equals negative 1, right? Well, how do I figure out what the secant is? It's pretty difficult for us to do this. It's difficult for us to do cosecant, and it's difficult for us to do cotangent. So what we can do is remember what our reciprocals are. That remember, cosine is the reciprocal of secant. So I can say then that use the cosine is equal to the reciprocal of 2 over 1, which would be 1/2. And cosine of secant of negative x is still going to be negative 1. Does everybody see why I did that and how I did that?
Yeah.
We can, but it's very difficult to find what secant is on the unit circle, right? We know cosine is our x value, our sine is our y value, and tangent is y over x, right? We know those kind of two are easily, and we also know the unit circle. So if I don't, secant's kind of hard for us to visualize where it is on the unit circle. So what I can do is, if I rewrite it as a cosine, then it's now easy for me to say, oh, okay, I know cosine 1/2 is on the unit circle. I know cosine of negative 1 is on the unit circle. Make sense? So just remember, because secant and cosine are reciprocals of each other. So now I need to figure out, or remember, where is cosine of 1/2? And I don't think I wrote this, but we have to be between 0 and 2 pi. So I write this up.
That's a good circle.
Thank you.
Can it be pi over 3, 5 pi over 3?
Well, let's see where 1/2 is. I'm sorry. 1/2 would be at this point. 1/2 radical 3 over 2. And it's also at this point, which is
5 pi over 3.
1/2 comma negative radical 3 over 2. Well, this angle, like I said, is pi over 3. And that angle is 5 pi over 3. So you could say x equals pi over 3, 5 pi over 3. And then where does cosine equal negative 1/2 or negative 1? Well, negative 1 is only at this point, which would be at pi.
Pi. It's at pi.
How come you never had pi?
Hey, can we have like some
Does that make sense? Does anybody have any questions on this?
Chocolate pie. Did you just say chocolate pie?
Does anybody have any questions on this?
No, I get it.
In a serious, non-chocolate pie manner.
I get it.
Thank you.
You good?